screen. So what is hybridization? What is hybridization? Who can tell me? What is hybridization?
Ma'am, mixing of different orbitals under comparable favorable symmetries hybridization.
Yes, so that means the intermixing of orbitals. Hybridization is a process for intermixing of orbitals of slightly different energies. Okay, so that redistribution of energy will take place, and it was formed a new set of orbitals of equivalent energies and shape. Okay, so mainly intermixing of orbitals of slightly different energies, and after the mixing was done, redistribution of energy will take place, and a new set of orbitals will form with equivalent energy. So the first is sp hybridization. First one is sp hybridization. That means one s orbitals and one p orbitals will mix. Sp means one s orbital and one p orbital will mix with each other and form two equivalent sp hybrid orbitals. Okay, and here for sp hybrid orbital, 50% will have s character and 50% will be p character. Okay, 50% will have the s character and 50% will have the p character. Okay, now see how the hybridization will take place. So suppose this is the s orbital, okay, and this is the p orbital. This is pz orbital. This is s orbital. When these two mixed with each other, okay, when these two mixed with each other, then hybrid orbitals will form, and it is like look like a linear structure, and the bond angles become 180 degree, and it has a linear structure. Okay, so let's see the formation of BeF2 molecule. Okay, BeF2 molecule. Okay, so the electronic configuration of beryllium will be beryllium electronic configuration. Anyone?
Ma'am, 1s2
Yes, 1s2, 2s2. So if we write down its electronic configuration for valence shell 2s and 2p orbital will be vacant. This is ground state. In excited state, one electron will be shifting to the p orbital. Yes. So this actually, this s and this p orbital will form sp hybridization. Okay, now this suppose this is b, this is his hybrid orbital, intermixing take place, then it is mixed with suppose p orbitals of f, this is the 2p orbital of f, and it forms this linear structure. Understood? This is sp hybrid orbitals. Okay, now we have to find sp2 hybridization. Sorry. sp2 hybridization. Okay, so that means one s orbital, two p orbitals will intermix with each other. So it will have 33.3% x character, okay, and 66.7% p character. sp2 hybrid orbitals have 33.3% s character and 66.7% p character. And these sp2 hybrid orbitals will remain in the same plane, and it has a trigonal planar geometry. Let's see. This is 2s orbital. Okay, this is 2p orbital. And okay, this is pz, this is py, 1s orbital, 2p orbital. Now intermixing will take place and they form structure like this. So it has a geometry like this. Okay, and the geometry like this. These are, and these bond angle is become 120 degree, and the geometry is known as trigonal. Okay, trigonal planar. This geometry is known as trigonal planar. Okay, and they will remain in same plane. These three orbitals will remain in same plane. This is sp2 hybridization. Understood?
Yes, ma'am.
Okay, so let's see the shape of molecules like BCl3. Molecules like BCl3. Okay, so boron, electronic configuration of boron. Electronic configuration of boron.
Ma'am, 1s2, 2s2, 2p1.
Yes, 1s2, 2s2, 2p1. So let's see its valence shell configuration. 2s2, 2p1. So this is in ground state. In excited state, 1s electron will move to the p orbital. In excited state, 1s electron will move to the p orbital. So this 1s orbital and 1p orbital will hybridize and form sp2 hybridization. Okay, this 1s orbital and 2p orbital form sp2 hybridization. Now let's see how they will form the structure with chlorine. So this is okay, and chlorine and form structure like this. Okay, and these are sp2 hybridize and chlorine will form, and in this way okay, trigonal planar. And this bond angle bit is 120 degree. Clear sp2 hybrid orbital?
Yes, ma'am.
Okay. Now is sp3. sp3 hybridization. sp3 hybridization. Now, obviously, here one s orbital and 3p orbital will intermix. sp3 means one s orbital and 3p orbital intermix with each other, and sp3 hybridization will form. So let's see. One s orbital, okay, one p orbital, obviously it will be 2pz, okay. So one s orbital, 2p orbital, 3p orbital, sorry, one s orbital and 3p orbital will intermix and form sp3 hybridization, okay, and form sp3 hybridization, and it has a structure of, okay, trigonal, that means tetrahedral. It has a structure of tetrahedral. So this will be the structure like this. And the bond angle will be 109.5 degree. 109.5 degree, and it form tetrahedral structure. Okay. Now let's see the formation of methane molecule CH4. CH4. So the electronic configuration for carbon,
Ma'am, 1s2, 2s2, 2p2.
1s2, 2s2, 2p2. So if we consider ground state, then 2s2 contain 2 electron, and in excited state, 1s electron will go to the p orbital. Now these 3 orbital become half filled and intermix with each other and form sp3 hybridization. Okay. Now here this C this sp3 hybrid orbital will mix with hydrogen now. These are hydrogen, and it will give a tetrahedral structure. Sorry. and the bond angle become 109.5 degree. Okay, so that's why, as it has three half-filled orbital, now that's why they are forming sp3 hybridization. Now we will see the structure of ammonia. See the structure of ammonia, NH3. Okay. Now, in case of ammonia, okay, so electronic configuration for nitrogen will be what? 1s2, 2s2, 2p3. For nitrogen is what? For nitrogen, 1s2, 2s2, 2p3. So here, if I draw this one, this s orbital, this 2s and 2p, this 2s and 2p orbital intermixed with each other and forms sp3 hybridization. Now here you can see, here one lone pair is available. Okay, so how nitrogen will form the structure C? This lone pair will not bond with anyone, and the other orbital, other hybridized orbital will form bond with hydrogen, and it form a bond like this. Okay, and the bond angle become, this bond angle become 107 degree, because you know that according to VSEPR theory, this bond pair and lone pair repulsion is more than that this bond pair repulsion. This bond pair and lone pair repulsion, this repulsion are more than that of bond pair repulsion. That's why bond angle become and that means it has a that means distorted structural form. It will structure form. This structure is known as pyramidal. This structure is from a pyramidal structure, and it is become, because of the presence of lone pair, the structure become a distorted structure, and bond angle become 107 degree. Understood?
Yes, ma'am.
Okay. Now next, the formation of water. Here, configuration of oxygen, electronic configuration for oxygen, 1s2, 2s2, 2p, 4. Okay, now for ground state, sorry. Now this 2s and 2p are forming sp3 hybridization. This lone pair and these are present as lone pair. So what will be the structure C for water? These are for hydrogen. So it form a structure like this. Okay, and bond angle become, this bond angle become 104.5 degree. This bond angle become 104.5 degree. Here is also lone pair repulsion. This lone pair repulsion is more than that of lone pair repulsion. So that's why the structure become distorted. It have to form a tetrahedral structure. Okay, but because of the presence of these two lone pair, the structure become distorted. The bond angle decreases. And it is decreases to 104.5 degree, and it have a V-shaped structure or angular structure. Understood?
Ma'am.
Okay. Now next is so sp2 sp3 we have done. Next we will do, that is sp3d hybridization. Sorry. So here one s orbital, 3p orbital and one d orbital will intermix with each other. Okay. So obviously here see 3s orbital, p orbitals are px, py, pz orbitals, and here 3z orbital, 3dz. Okay, 3z square this orbital. That is 3d z square orbital will intermix and it forms a structure like this. And it forms trigonal bipyramidal geometry. It forms trigonal bipyramidal geometry. Okay, let's see the formation of PCl5. PCl5. Okay, so the configuration for phosphorus will be, for phosphorus is 3s2 3p3. Here we are 3 is taking, because if we take 2s and 2p3, 2s 2p orbitals cannot form sp3d because d orbital is not present over there. So phosphorus in ground state form the electronic configuration like this. And d orbitals remain vacant. Okay, this is 3s, 3p, 3d. D orbitals remain vacant. But when we consider the excited state, then here one s electron will go to the d orbital. Now this s3p, this one s3p and d orbitals will intermix and form sp3d hybridization. Okay, then they form sp3d hybridization. Okay, clear? So here if I consider this one, see, for phosphorus in excited state, okay, now fluorine atom, 5 fluorine atom will form bond with it and it form a structure like this. It has a trigonal bipyramidal structure. Understood?
Yes, ma'am.
Okay. Now next is sp3d2. Next will be sp3d2. sp3d2. That means one s orbital, 3p orbital, and 2d orbital. So directly, let's see the structure of SF6 molecule. SF6 molecule. Okay, so we have to consider the central atom, that is sulfur. So sulfur has electronic configuration 3s2, okay, 3p4, and obviously the orbital will remain vacant. Okay, the orbital remain vacant. So in excited state, one electron from P and one electron from S will move to the d orbital. This is 3s, 3p, 3d. So this will form sp3d2. This will form sp3d2. Understood? Yes, understood or not? Okay, sp3d2. So
Yes,
it
ma'am.
has a structure of octahedral. Structure of octahedral, like it has a structure of octahedral. So it has the octahedral geometry. Clear?
Ma'am.
And the last one is sp3d3. Last one is sp3d3. So here we will consider the formation of I7F molecule. So that means iodine fluoride. For iodine, the valence shell electronic configuration become 3s2, 3p5, 3d will remain vacant. Okay, so in excited state, one in excited state, okay, electron shifted. So it formed sp3d3 hybridization. Now, if we consider this excited state configuration, and if fluorine atom will mix with each other, they form bond, fulfill the, okay, and then it form a trigonal bipyramidal structure like this. So if it's a central atom, it form a trigonal bipyramidal structure. Okay, so sorry, pentagonal. It forms a pentagonal bipyramidal structure. Okay, and the last one is DSP2. DSP2 hybridization. Okay, they have square panel arrangement. square panel arrangement like this. Let's see the geometry of nickel carbonate molecule. Okay, nickel cyanide, a complex ion. Nickel cyanide. So nickel has the configuration like this. D orbital. Okay, so it has a configuration is 3d8 4s2. So 1, 2, 7, 3d8 and 4s2. Okay, so nickel 2 plus will be have the configuration of this one. This 2 electron will move because nickel 2 plus okay. Now in case of Ni CN whole for 2 minus, see how the hybridization take place. Okay. So here this CN for CN ion will be hybridized and they form bond like this. This one. And this is become what? DsP2. So they form DsP hybridization and have a planar structure like this. So this is the DsP2 hybridization. Clear? If you have any confusion, you can ask me. So I thought
No,
that.
ma'am.
Okay, so thank you everyone. I'm ending the class now. Tomorrow we will do a few examples of those. Okay. So thank you everyone.
Thank you, ma'am.
Thank you, ma'am.